Hello everyone. This is the first of hopefully a few posts for showing how my solar project is going and how things are connected, what we've got going on, what my plans are. Hopefully get some good comments from you guys to help me out on what I'm doing, explain a few things, maybe catch some things that I'm doing wrong or potentially could be doing wrong. I guess to start the description of what I have here is I have a 7 amp charge controller, which is blinking, so it's getting a little bit of charge there. It was just going off or blinking pretty fast, which meant it was actually giving the battery a pretty good charge. As you can see, the voltage reading from the solar panels, it's a little bit over 13 volts, which means it's not great. Earlier it was like almost 18. I guess the cloud must have just covered my panel or covered the sun up there. We'll see if it changes. While I'm videotaping this, I'll come back and show you how it's actually blinking when it's a lot faster or giving a better charge. And that controller is actually charging these batteries here. These two batteries are batteries that I've taken out of an old UPS system, which I think these batteries are bad, so I figured I'd just put them on here to see if I could bring them back to life with that charger. These two batteries I have charged. I charged them with the charger previously, and they've got a pretty good charge. They're good batteries. I'm going to keep them as spares or maybe use them if I get another project or something. Thinking about putting some outside lighting with the solar system here as well, so that might come in pretty handy. Here we have the circuit breaker for the power coming out of the batteries into the power inverter, and as you can see, it's got a black and a red cable. Reason for that is because I ran out of red cable, and this ground wire here, I actually have it and I'm going to use it for my final installation, but I did not want to cut it up or do anything with it, and I didn't want to have to run out and to the parts store and get any more cables, so I'm just kind of using it. This is all a test. As you can see, all of this wiring is just kind of halfway there. When the final system is actually in place, it won't be on this door. It's basically just kind of screwed into a door that I had a little spare door here. I'm just kind of using it as a backboard, and for sure won't be on that. It'll actually be on something, don't know yet, but whatever it's in, you won't see half of these or more than half of this wiring. Everything will be in the back of the board. You'll just see the little dials and things that you're supposed to see. So here we have the amp meter that's actually showing what the amperage from the solar panel is. That's connected through the shunt that then goes into my charge controller that charges the two batteries that I currently have, and I plan on getting some more. Here we have the voltage reading from the batteries. As you can see, it's pretty good amount of charge, which means the batteries are good. So the charge controller isn't trying to do any charging right now because it does detect that they have a full charge. My fuse box here, currently it's a 6 outlet or whatever 6 device box. Currently I only have these 3 things on here, which is my meter, my charge controller, and my recently purchased battery charger. I was hoping not to have to use a battery charger for the system, but the reason that I did do it was because we had a lot of bad coverage here, or sun coverage, and I wasn't getting a good enough charge or fast enough charge that I needed so that I could run my test. I came back here because, as you can see, or if you can tell, the lights are blinking rapidly, which means the sun just kind of came out, and when that happened, we noticed that the voltage on this guy went up substantially, so we're getting almost 18 volts out of the system, which is great. Back to our charger or battery charger here. My battery charger is actually connected through this relay, and the way I currently have the relay set up is when the relay detects power from the from the solar panels, it actually turns itself to a open position, which means that then the charge controller will be charging the batteries. So that's more like during the day type operations. The batteries will be charged through the solar system, and in the evenings when the solar panel shuts down, the relay will flip over and actually then begin charging through the battery charge controller. The battery charger. And the battery charger that I have is actually a relatively smart charger, and it can detect when a battery is connected to it. Thus, the relay failing over creates that connection, and then the charger begins to charge. And I have it on a maintenance charge just to make sure it doesn't overcharge the batteries or do anything funky like that. So it looks like so far it's working pretty well. Keep monitoring the system just to make sure nothing goes wrong and that the batteries don't get overcharged or anything, but it also has a cutoff switch to prevent that. We'll see. Here are my two batteries. I have two Optima AGM batteries connected in parallel. They're 55 amp hour batteries, so roughly we got about 110 amp hours of battery life. I have yet to test that. Hopefully later on today I will get to test that. I have a 2000 watt inverter, which is a 4000 watt surge peak power, which is connected to, or my kilowatt meter is connected to it. This connection you see here actually goes to my power transfer switch that I will not show you yet. The power transfer switch is actually connected to my UPS system. The way that works is, the power just goes back and forth between the solar power or the batteries and the UPS system. The UPS system has been a very, very good item for us to have here at home, because when we've lost power previously during hurricanes and stuff, has actually allowed us to keep power while we were allowing our generators to cool down and things like that. And I was getting about a 6-hour runtime on those with about 500 watts. And I just recently purchased another battery for that system, so I'm hoping to get maybe in about 10 hours or so, we're using the same amount of power, and which eventually I would hope to get something similar out of the solar system so that I can have a pretty good amount of backup time. This system I'm going to test with about 1,000 watts of power of draw, basically connecting the refrigerator, TV, a few lamps, anything else I can think of that could bring the draw to about 100 watts or so. As you can see, I'm using the kilowatt meter to measure that, and 1,000 watts I think will give me more than sufficient devices running, that I don't have to worry about needing anything. Of course, it's not going to run my central air or anything, but eventually, if we can build the system good enough, we'll work on getting that in there. But for now, thank you guys for watching my video. If you have any comments or you see anything that I've done that's obviously wrong, or any of you guys who really know what you're doing see that I could potentially be messing something up, let me know, and I will definitely take all your comments into consideration. And again, thank you guys for watching this video. For those of you who have posted your own, thank you for posting, because I've actually used a lot of those videos to help me determine what it is that I need to do here. Thank you guys.